Let us see a few examples, typical kind of examples for solving the quadratic equation. The first one is, the numbers are looking very weird. Root 3x squared plus 10x plus 7 root 3. Though the numbers are slightly looking complicated, we follow the same method of factorization. If we have a coefficient of x squared other than 1, we multiply with a constant term. So that gives 7 root 3 times root 3, that is 7 times 3, 21. And then we find the factors of 21 which add up to 10. And the 21 has a limited number of factors, that is 1 times 21 and 3 times 7. And very easily we get our required pair of factors. So we just split the middle term 10x into 3x and 7x, keeping the first term 3x squared as it is and the last term 7 root 3 as it is. We follow the same method of splitting the middle term, though the numbers are looking little bit different. Now we make groups and take out common. In the second group, you can easily say that 7 is common factor, so x plus root 3 is the remaining factors. From the first two terms, you can see clearly x is common, but if you split 3, we can write 3 as root 3 times root 3, square root of 3 times square root of 3. So now we can see we have another factor of root 3 as common. So from the first two terms we have root 3x common, and the remaining factors are x. We have taken root 3 one time common, so one time root 3 is left. And we had already seen here it is 7 times x plus root 3. So we see again x plus root 3 is a common factor, and the remaining factors now are root 3 times x plus 7, which is equal to 0. So now we got the factors of the numbers with the equations with irrational coefficients. Root 3 is an irrational number. So for irrational numbers, we got the factors. Now using zero product rule, we can say x plus root 3 equals to 0, or root 3x plus 7 equals to 0. And this gives now x equals to negative root 3 as one of the solutions, or we have another solution as x equals to negative 7 by root 3. Now these are the two solutions, and here we need to slightly modify this solution, as we generally do not keep an irrational number in denominator. So we rationalize this by multiplying the numerator and denominator by root 3. So we get x equals to negative 7 root 3 by 3 as the another solution. Now here it is a special case. This case, in general, the equation is in the form of under root of ax plus b, square root of ax plus b is equal to cx plus d. Though it does not appears to be a quadratic, but we can modify, we can rearrange and get the quadratic form of equation from this. We know very well, to remove square root, we need to square both the sides. So when we square both sides, the square root on the left hand side is removed, so 2x plus 9 and on the right hand side it gets 13 minus x the whole squared. And what is 13 minus x the whole squared? It is a squared, that is 13 squared 169, minus 2 times a into b, that is 2 times 13 into x, so that is 26x, plus b squared, that is x squared. So using the identity of a minus b the whole squared, we have to expand the right hand side. Still the left hand side remains the same. Now collecting all the terms on one side and rearranging it in this standard form, we have x squared as it is. We transpose 2x, we subtract 2x from both the sides, so we get negative 28x. And then we transpose 9 also, or subtracting 9 from both the sides, we get plus 160, e remains equals to 0. So we have converted this form into standard form of a quadratic equation, and then we can use the method of factorization to solve this. So let us see how do we get the factors of 160 which add up to negative 28. So it is 1 times 160, it will not go, 2 times 80, 4 times 20, it's closer but still no. Then we have 8 times 20, and here we go. We want negative 28 as the sum and positive 160 as the product. So we take negative 8 and negative 20 as the required factors. So we can write x squared minus 8x minus 20x plus 160 equals to 0. And then regrouping and factorizing, we have x times x minus 8, and from the other group we have negative 20. So again x minus 8 equals to 0. So now again we have x minus 8 as common. So x minus 20 equals to 0. So we have product of two numbers as 0. So using zero product rule, we can write x minus 8 equals to 0 or x minus 20 equals to 0, which gives x equals to 8 or x equals to 20. Now here, this is not the end, this is not the final answer. We need to check whether x equals to 8 and x equals to 20 satisfies the given equation. So we put x equals to 8 in equation 1. Putting x equals to 8 in equation 1, we have left hand side 2x, that is 2 times 8, that is 16, plus 9, so that is 25, square root of 25, and that is 5. And right hand side, what do we get right hand side if we put x equals to 8? 13 minus 8, so that is 5. So after verification, we can say that x equals to 8 is the solution. Now let us check the another one. If we put x equals to 20 in the given equation, what do we get the left hand side? 2 times 20, that is 40, plus 9, that is 49, and square root of 49 is 7. And what do we get right hand side? It's 13 minus x. That means 13 minus 20. And 13 minus 20 is negative 7. So you see left hand side and right hand side are not equal. Though we are getting x equals to 20 as the solution of this equation, this is modified version of the given question. So this is an extra solution. The solution which does not satisfy the given condition, they are called extraneous solution. Our question was to solve this equation. Square root of 2x plus 9 equals to 13 minus x. And out of these two numbers, 8 and 20, only 8 satisfies the given condition. Though 20 and 8 both satisfies this condition. But our task was to find the solution for this question. So, x equals to 8 is the only solution for this given question.